Okay, I'm just setting up the live stream. Just give me a minute. All right, so I'm starting to record this session. Okay. Session is being recorded. And I hope my white screen is now visible, correct? Whiteboard is visible?
Yes, sir.
Okay, superb. So today's discussion is going to be on week 4 content. And an update before we start, the TA session, which was supposed to be on 26th October 2024 from 5 to 7, this has been preponed to tomorrow, which is 23rd October 2024, same time, 5 to 7. This is being done for two reasons. The first one, since our quiz is on the 27th, a revision session on the 23rd might help you better. So we have preponed it. And also to give our TAs the benefit to prepare for the quiz on 27th for their respective courses, right? So please note this. The TA session has been postponed to tomorrow. The calendar has already been updated. An announcement is also being sent. It was also sent now. So just check. Okay. So that is something that you'll have to note. And the TAs have already covered weeks 1 to 4 content. So tomorrow would basically be a discussion on any doubts that you have. So please prepare accordingly and go for the session. In today's session, we will look at week 4 from an instructor point of view, where we'll look at some interesting concepts around elasticity and regression. Fine. Okay, so before I start, any doubts from weeks 1 to 3? Any doubts in weeks 1 to 3? No doubts, all good. All right. Okay, then we'll start with week 4. One more thing. We have configured. Yes, go ahead, Aurora.
Will PP plots come, like, is it there in the syllabus, PP and QQ plot?
On PP and QQ plot, we have discussed now. So what is the purpose of PP plot? What is the purpose of QQ plot? So it is there.
Can you do a quick recap of it if possible?
You want to do on PP and QQ? Okay. Well, fine. We'll do PP and we'll do QQ. So what have you understood from PP and QQ? Even I would have talked about this. So what is your understanding of a PP plot? What is the full form for PP, first and foremost? Anyone?
Percentile.
Percentile.
It's probability.
Sorry, probability.
Probability plot. Okay. So what do you plot here? Anyone? What do you plot in this probability plot?
Probabilities of sample versus model distribution. Model distribution.
What versus the theoretical distribution. So it is basically a plot that you have the theoretical probability and you have the, let's say, sample probability. What is the probability theoretically of observing a value? What is the probability of observing the value in the sample? So you plot this. This is what you can get. Okay.
Sir, in this theoretically observing the probability means what does it mean? Sample probability is observing the data points.
So you are given a data of, let's say, you are given a deck of cards. Okay, what is the probability of finding a king? What theoretically in a deck of cards, what is the probability of finding a king?
4 by 52.
4 by 52.
52.
Right? So this is the probability of a king. Now, what you are given is, from that I'm randomly shuffling and taking out 10 cards and giving it to you.
Okay.
In that, how many kings you have? You have 1 out of 10. Let's say you got only 1 king. 1 out of 10. This is the sample probability.
Okay.
This is the theoretical probability.
Got it.
Got it? So if I plot this for the different values, I will get a graph. That graph is known as the probability graph. And what is this used for? Using this graph, what will it show? Highlight? Anyone?
It will highlight the middle portion of the distribution.
Center of the distribution. So is the center of the distribution for the sample and the theoretical probability matching? That is what a PP plot will tell you. Okay? More likely, it will not tell you about the fringe values. It will be more concentrated towards the center values. Okay, what is a QQ plot then?
Quantile plot.
It's a quantile plot. So what is a quantile? Okay, how many quantiles are there?
4.
4, what are they?
First quantile, median, third quantile. Wait. I think 3 then.
There are only 3. So you have
Yes,
25 percentile, you have the 50 percentile, and then you have the 75 percentile, which are the 3 quantiles. In this, which is called the median?
50.
Q2 is called median.
This is the median.
So, sir, that is quartile or quantile?
It's quantile.
And then what is quartiles?
People say the same thing, man. Quantile. Some people might even take 15, 25, 50, 75, 90 above. So that is also possible. So quantile is what we use.
Although you were saying quartiles, interquartile range, IQR, and all, it is quartile is what we have been taught. Is quantile, is it?
Quartile, okay. Maybe
Quantile.
pronunciation difference. Whatever is said in the video is the same thing that I'm repeating here.
Okay.
Right? So you have Q1, Q2, Q3. Okay, so this is what it is. So here, what you do is, from the sample, you take the first 25 percentile of values, see where it sits. Then you take the 50 percentile of the values, see where it sits. And then 75 percentile. And then compare it with the theoretical values. And you get the QQ plot. What is this used for?
For the tail,
For the center,
to
this is
know
for the,
about the distribution at the tails.
this is about the tails. Why is it very valid for the tails? Why is it very valid for the tails? Any guesses?
Because maybe it takes care of the first quantile and the third quantile also.
Because it looks at the 25 percentile, 75 percentile. Even if values are varied, let's say you have a big spread, then what will happen is, in your actual data, and you took from one end of your sample, most of them will either fall here or here or here. So the other two will capture where they are not falling. Making sense? So this is why the QQ plot captures the tails and the PP plot captures the center. Because it's a probability value where every number is seen, and as it goes towards the center, the probability should increase. So this captures the center, this captures the tails.
Sir,
Okay.
can I have a question here, sir? Actually?
Yeah, go ahead, Alan.
There is 50 percentile is also there. So I can think while 25 and 75 is justifiable for the tail. Since you are capturing 50% as well, then why are you doing tails?
No, what I'm trying to say is, you have, let's say you have a data set which has come between the 25 and the 75, 25 and the 50.
Okay.
Then what will happen? The 75 will not match.
Okay.
Only if you have a data that is evenly spread, having values from all the three, will
Okay.
both your sample and the theory match. If not, in one of them, or in one of those two, it will get hit.
Okay.
If you take only from the center, the tails will get hit. If you
Yeah.
get only from the tails, the center and the mid, the other tail will get hit.
Correct.
Right? So, if you have a sample which is extremely thick on the tails, right? If you, let's say, have a distribution that looks like this, which is extremely thick on the tails, right? From this distribution, if you get samples only from this guy, this will not match, this will not match. If you get samples only from these two, then this will not match. Even if you have a distribution that looks like this, then if you get a sample, this will not match because this is a thick tail, right? That is the purpose of a quantile plot or a QQ plot. My pronunciation is very
Okay.
okay. Right? Clear? The person who asked me this.
Yes, sir, clear. Thank you.
Good. Any other doubts from weeks 1 to 3?
Sir, I have a doubt in week 3.
Go ahead.
How to interpret significant level with tabular value that PA questions are I am unable to solve, sir. Could you please guide me?
Which one?
Practice assignment 3.
1 second. Let me just open it. Practice assignment, right? So even an old version should work.
4, 5, 6 with same concept.
1 second. Okay, this is an old version. I do not have the latest to this thing. I only have backend access. I'll open this. Practice assignment 4. Sorry, practice assignment 3.
Yes, sir.
BA3. Question numbers?
4, 5, 6.
Okay. Based on the given sample data on the choice of electives by students by sections A and B, you would like to make inferences on the entire population. Therefore, you call chi-square test of independence. Okay. At a significance level of 0.05, the chi-square tabulated value is 3.84. Okay. What do you conclude? For this, what you should do is, for this, have you calculated the chi-squared value over here? Let's say I submit this guy. Check answers. Okay. Let me submit this guy. What is the calculated? Okay, so question does not ask for a calculated value. Okay. What you should do is, for the table, for this table, you must do a computed chi-square. You must calculate the chi-square value, computed chi-square. Okay. Fine. So once you get computed chi-square, if this guy chi-square is greater than your chi-squared alpha gamma, which in our case is going to be alpha of 0.05, alpha is 0.05, and gamma is going to be section AB 2 by 2, right? So 1. So in our case, this if this chi-squared is greater than 0.051, which is being given as 3.84, if this happens, you will reject H0. Else you will accept, which basically implies you will accept HA. Am I correct?
So do not so it's
not
changed to
reject
reject H0.
Very good. Okay, all of you are awake. So this you should never say. Always remember that if the chi-squared value is just greater than your chi-squared tabulated value, which is what is given. So the value that is given here is the chi-squared tabulated value, 3.84. So whatever you compute, if it's greater than 3.84, you will reject H0. If it's less than 3.84, you will fail to reject or do not reject H0. Okay? Making sense? And the same thing happens for this guy also. So if you see, as the alpha value reduces from 0.5, it becomes 0.01, the chi-squared tabulated value will increase. Okay? So in this case, you will, okay, here you are still rejecting. In this case, you fail to reject. So
Because the calculated value is coming to around 7.8, sir.
it's coming 7.8. Okay.
Yeah.
So the calculated value is 7.8. So as long as the tabulated value is less than 7.8, you will reject H0. And once it is greater than 7.8, which is 10.8 at 0.01, you will fail to reject H0. That is the theory. That is the concept that is being checked by these three questions.
Okay, sir, got it. Thank you.
Anything else?
Yes, sir.
So how to get the p-value without the chart?
You can't get it without the chart. You need the chart, or you need a software.
Because there was one question in the PYQ, it was asking for,
Very often, maybe someone would have made a mistake.
Okay.
Because in the beginning there were several people who were handling the course. At that time they would have done something different. You cannot compute it. Just search the discourse for very old questions. You will see that there were a few errors that had happened, which were rectified. Which brings me to the point. Mostly by tomorrow, your mock questions. Yeah. Mostly by tomorrow, the mock questions for weeks 1 and 2 will be released. It's already configured. They have missed to release it today. And weeks 3 and 4 would be released maybe by day after tomorrow, by Thursday. Okay. So just check the mock unit. Mock for week 1 questions, week 2 questions, then separately for week 3 and week 4. You'll have 4 weeks that are coming out, and these are basically the previous question papers, at least 5 to 6 of them. We have combined all of them, solved it, and put up those questions over there, so that any corrections that are made would be reflected in those. Fine. But yeah, you cannot compute p-value by hand without the tables.
Okay.
Someone else add something else. Bhavana.
Yes, sir.
Yeah, go ahead.
Sir, I have a doubt in practice assignment 2, question 6. Here they ask if the kurtosis is greater than 3.
Question practice assignment 2, question number 6. 2, 4, 5, 6. If the kurtosis is greater than 3, okay. Okay. So what is the doubt?
Oh, sir, I don't get the answer. The answer is heavier tails, normal distribution. As I search in Google, it says kurtosis is greater than 3 can be visualized as a thin bell with a high peak. So thin bell, so it means tails are thinner. Lighter.
Let me just check this once, maybe. And just check this once because I'm also not able to get it. Immediately get it. Kurtosis is the tail portions. Greater the kurtosis, thicker the tails. Thicker the tails, correct only. It should be more in the tail. The answer is correct. Heavier tails and a normal distribution. Let me just check why Google says that, and I'll get back to you. All right, just post it in Discourse and tag me and the TA. I'll come and respond. Okay.
Sir.
It is correct. No, as the kurtosis increases, The weight in the tails increases. If my memory
Because
serves me.
in Google they say whereas the decreased kurtosis corresponding to a broadening of a peak and thickening of a tail.
Thickening of a tail, right?
When less than.
When less than thickening of a
Yeah,
tail.
whereas a decreased kurtosis.
No, I will check. I will check. As kurtosis increases, thickness of the tails increases. Because there is skew, it gets skewed to one side. The peak gets skewed to one side with a long tail, but the thickness of the tail increases as the kurtosis increases. So let me just check that once. It's been very long. I could be wrong. I'll just check once and I'll get back to you on Discord. Okay?
Okay, sir.
I don't recall this. Okay, I'll have to check. I'll have to revise. Okay, I'll get back to you on this Discord.
Sir, what is the formula used for kurtosis?
It's a big formula, man. It's the third. Kurtosis is the fourth movement. Kurtosis.
I think the fourth mean divided by the, I think.
Yeah, it's the fourth movement.
Deviation, deviation.
Fourth movement. Kurtosis is the fourth movement. That is why this thing. Mean is the first, standard deviation, skewness, then kurtosis. So kurtosis is the fourth movement.
So this type of question is coming in the examination.
You asked me. I'll clarify it tomorrow. I'll just make a check. This could be wrong. Let me just check. But my memory tells that it is not. I'll just check once more because in Google it could be for a very specific reason. I will pull out the reference. I'll check with the statistics textbook and then I'll get back to you.
Because I write it, kurtosis greater than 3 is recognized as a leptokurtic.
Leptokurtic.
So means thin. Less than 3 is a platykurtic. Platy means means broad. The broad in sense of middle part or its tail type. Lepto, where it is.
Actually, it says if the kurtosis is greater than 0, it has fat tails and a sharp peak, indicating more outliers and extreme values. Example, heavy tail distribution.
Very long and skinny tails. Long and skinny tails. Correct only. Look.
Yeah, heavy tail distribution like T distribution comes under kurtosis for greater than 0.
It's called leptokurtic. So leptokurtic is having a very long and skinny tails. It could be skinny, but it's long. So there are more values in the tails. So that is what this question is asking.
It means heavier tail.
No. You can you don't have to call it heavier. You can call it more values in this thing. The peak is very skewed. Once again, what is this question? Here now. Look, what does the data set says? The data has heavier tails and a normal distribution, more in the tails. That is why we have said more in the tails. So when you look at leptokurtic, thank you, I don't need an Apache bike. Look at the leptokurtic. What happens? It has a peak value, then it has values everywhere. So then it becomes a leptokurtic. The tail would be long. So a leptokurtic is having very long and skinny tails, which means that there are more chances of outliers, which is what we mean by heavier tails. Positive value of kurtosis indicates that the distribution is peak and possesses thick tails. When they say thick, long, large number of values in the tails, which is why we have used the word heavy. Okay, so it is correct.
Okay.
Fine.
Lots of outlier, that's why.
Lots of outliers. Lots of you do not have to call it outliers. You can, if there are a lot of numbers on the tails, you don't call it an outlier. No, an outlier is a very rare event. So when you have a lot of values in the tails, it's not that it's outlier, it has a lot of tail values, lot of extreme values, or long extreme values. Fine?
Okay.
Right? Making sense? Did you understand? Not understand?
Yes, sir. So where we find this type of you have a.
That did you find?
This PDF type where we.
Just Google search, ma.
Okay.
Just general Google search. You just go to Google and you search kurtosis. Third link. kurtosisdatascience.com. No, it's not coming. Okay.
Okay, thanks, sir. Let's
Probably this is the first one. That is the same. Okay. Everywhere it's the same thing. Leptogatic, mesogatic, and platogatic. Platogatic. Mesogatic is a normal distribution.
Yes. Standard normal distribution, mesogatic.
You don't have to call it standard normal because standard normal means mean has to be 0, variance has to be 1. But it's just a normal distribution. That is what. When you standardize anything, it will become 0, 1.
Sir, I write it on the Google's after searching that as where they write a standard normal distribution at kurtosis of 3 and is recognized as a
Why do you standardize? You standardize it to bring it to some base value for comparison. So any distribution I can always standardize by minusing it to the mean and dividing it by the standard deviation. X minus mu by sigma is that only, no? So you standardize it and then make a comparison. So you just say mesogatic is standard normal. Any distribution, once you convert it to a standard normal, any normal distribution can be converted to its standard form with a mean 0 and variance of 1.
Okay.
Right. Any other questions?
So you told that you will release the solved PYQ, sir. When will
Yeah, it's going to come. You will get weeks 1 and 2 tomorrow, and weeks 3 and 4 maybe by Thursday. They have configured this, but they forgot to release it.
in the supplementary content or in the discourse?
It will be in a separate module known as the mock unit, where you will have week 1 mock for week 1, mock for week 2, then mock for week 3, mock for week 4, and it will come.
No, sir. I think he's asking about last week. You had told us that PYQs will be.
That is what I'm trying to say. Those previous year question papers are going to be combined together, solved, and going to be given to you as mocks.
Oh, solved. But then mock means we'll have to solve.
No, you can solve the question, check the answer.
Answers. Okay.
Yeah, you can input it and check it.
Okay.
Those are all previous year question papers.
Okay.
All are for the first 5-6 terms, whatever question papers that we have combined all of them, pulled out week 1 questions, week 2 questions, and combined them and given it to you.
So is it enough that we do all the whatever mocks that are going to be released and with along with the PAs and GA1? Is it enough for?
You're asking a faculty to tell you whether it is enough to study only a previous year question papers.
No. I'm asking if you have already covered all the questions in this mock, then we don't again go back to the PYQs and start solving.
No, you don't have to go back to PYQs. Like I said, we have taken the past 5 PYQs. Okay. Before that, if you find any errors, all the best. You will have to find the solution on discourse. That is the only thing.
Okay.
The past 5 question papers we have combined.
Okay. Thank you, sir.
Anything else? Okay, we'll start with week 4. If you have any questions, always welcome to ask. Okay, so what is the topic covered in week 4? What are the topics that are covered in week 4?
Elasticity.
Okay, only elasticity, yeah?
No, not only elasticity.
Elasticity. And there is one more.
Linear
regression.
And simple linear regression, SLR. So these are the 2 topics that are of focus in week 4. Even that, what you should identify is SLR is used as a technique in the concept of elasticity. That is how it goes. Okay. So in elasticity, what any economic student here? Anyone with a background in economics here? Okay, so I've got a Bakrap, Nayong, okay, Pari, Azana Pari, okay, Nayok and Azana Pari. What does elasticity mean? I get Bakras, I'll ask questions.
Change in demand with respect to change in price.
Only that, and it's only change in demand?
Quantity demanded.
Only change in quantity demanded, is this right? Change in quantity demanded by change in price, is that correct? Hazan, is that correct?
So, I'm kind of confused because I'm a physics and economics student.
Very good. With an economic, you are an economic student at the end of the day. So is this correct? Something is wrong here.
It is basically when one changes with respect to the other.
Correct.
The price of one will change with the respect of the other.
Correct.
So
but is this correct? Just
percentage of change.
it should be percentage change in demand by percentage change in price. This is elasticity, but this is one type of elasticity. What type of elasticity is this? Nayonika, what type of elasticity is this?
So, what type?
This is price elasticity because price is in the denominator.
Yeah. This is price elasticity. Good. Then what are the other two types of elasticity that are left?
Demand, income elasticity also, right?
It is income,
cross elasticity,
and the cross price. So these are the three economic or primary economic related elasticities that are there. Have you studied all of these three in BDM in the new syllabus? Anyone who took BDM last term?
No, sir. Last term.
We didn't learn last term.
All right, okay. So these were in the terms before that. This is known as price elasticity. You have income elasticity and you have cross price elasticity, these types. But in our course, we are going to focus only on this. In BA course, we are going to focus only on price elasticity. And the important thing to note about price elasticity is that it is always represented as a absolute number. What is an absolute number? You always represent the mod value of price elasticity. You always represent it as the mod value, right? So that is the most important thing. So even if your elasticity is this, you will represent the mod value and say the price elasticity is 3. Okay. So that is the first thing that you'll have to remember. Whereas for income, sign is important. The sign becomes very important in income and in cross price. Both of these, the sign is important. In price elasticity, only the magnitude is important. Okay. So that is the first thing to put it in your mind. Okay. So if magnitude is important, how is price elasticity classified? So if I get a price elasticity number, let's call it epsilon, since that is the symbol that we are using in our course. The value of epsilon leads to two types of items. What are they? What are they?
So elastic and inelastic.
Super. You have the elastic and the inelastic items. So what is the value for items which are elastic? What range of this thing do you call it as an elastic item, elastic demand?
So when epsilon is greater than 1, we term it as an elastic demand. And when it's less, And when it's less than 1, it's an inelastic demand.
Okay, we can call it less than or equal to. You call it, it's basically when it's 1, it's perfectly elastic and stuff like that. But anyhow, so it is when it's less than or equal to 1, you generally say it is inelastic demand. As whatever is the change in price, percentage change in price, the quantity is also equally changing. Okay, so remember again, we are only looking at the magnitude number 1. We are not worried it's minus 3 or minus 5 or minus 0.01 or minus 0.02 or plus 0.02. We take only the absolute number. We take the mod value of epsilon and compare it with the number 1. If it's less than or equal to, it's inelastic. If it's greater than, we say it's elastic. Okay? Everyone with me so far?
Yes, sir.
Okay, super. So since we have economics in the room, if I have to write the formula for price elasticity, what is the formula? If it's going to be percentage change in demand by percentage change in price, how will the formula look like?
So, price elasticity, quantity of the goods divided by price. Change in quantity divided by change in price.
Percentage change in quantity by percentage change in price. That is what it's in words. Can you tell me in terms of numbers or in terms of notations? Mathematically, how would you write?
minus Q1 upon
quantity.
Q1.
Once again, Q2 minus
Q1 upon Q1.
Q2 minus Q1 upon Q1.
And in the denominator, P2 minus P1 upon P1.
P2 minus P1 upon P1. This is percentage change in price. You can just multiply it by 100. So it's basically going to be percentage change in price by percentage change in quantity divided by percentage change in price. This is the formula that any economics textbook will give you. But what is the formula that we are using in our course? What is that epsilon formula? That we have told you in this course in week 4.
Demand D of P1 minus D of P2 minus D of P1 by D of P1.
That is the same thing you are telling me in terms of D. That is
Yeah.
not the formula in the course that we in week 4 that we tell you. What is the formula in week 4 that we tell you?
So if it is linear, we give it by MP by
We are looking at only linear demand response curve.
So it is MP by D naught
So
minus
D naught minus MP.
MP divided by D naught minus MP.
MP divided by D naught minus
Yes,
MP.
Yeah.
So this is the formula that we tell you in the course. Why are there two formulas for the same entity? You remember this is also epsilon, this is also epsilon. Why do you think there are two formulas? What is the difference here? Any guesses?
So the first one is basically point elasticity. It is measuring point to point. Second one is basically linear throughout. So it is that's why the straight line.
Ulta. Whatever you told me, it's ulta. This is linear. Of course, this is not be linear. This is between points. This is at a point. So if I draw a curve, okay, before I draw the curve, you are drawing a demand response curve. What should be on the x-axis? What should be on the y-axis? This is the x-axis. This is y-axis. What is on the x-axis? What is on the y-axis?
So demand on y-axis and price on x-axis.
Why?
Because we are here, the y is the result, or basically the response, or whatever you call you. It's
exactly. So what you in some textbook you'll find it ulta. In economics textbook you'll put price and demand. It could be changed, but in mathematical terms, y-axis always carries the dependent variable.
Right.
X-axis always represents the independent variable. Here, price is what you can change, and you will see how much demand happens. Okay, so that is why the demand response curve has price on the x-axis, demand on the y-axis. It's not wrong to change it, it's just convention. Okay, so let's say you're looking at a linear demand response curve that goes something like this. Okay, here, this is point 1. This is 0.2. This is a linear curve. Okay, let's not even do that. Let's say you are given 2 points. You are given 0.1 and you are given 0.2. You are not told anything about the curve. You are told that there is a 0.1, there is a price P1, there's a 0.2, there's a price P2, and correspondingly you have Q2 and you have Q1. Okay, that is all you are told. Then, if you compute the elasticity using this guy, what you are computing for changing from 1 to 2, it could be any curve. It could be this curve, or it could be this curve, or it could even underlying be something like this. You don't know the curve. Then for a change between 1 and 2, what is my elasticity is what the first formula tells you. Between 2 points, what is the elasticity? Okay, so that is the first formula. Between points 1 and 2, without looking at the curve, what is the elasticity that is happening?
Is it not called point elasticity in that case?
No, it is not point elasticity. No, it is between 2 points. No?
Between 2 points, okay.
It is changed between 2 points.
Okay.
Right? Whereas you look at this guy. In this guy, what do you say? These two lines are on a straight line. And what is the elasticity at a point on that curve? If I have a price of, let's say, Px, then what is the elasticity at x? I get it as m into Px divided by d0 minus m into Px. So at the price, what is the elasticity? That is what this guy tells you. And you are getting this formula because it's a linear curve. Since it's a linear curve, I'm very easily getting it as mp divided by d0 minus mp. Let's not go into the derivation, not a scope for us. All of you clear? This is why this formula exists, why this formula exists.
So P is equal to price.
P is price. P is price. So
M is the slope.
M is the slope. So this formula comes from an underlying linear demand response curve of the form demand at price P is equal to D0 minus M into P, where P is price, M is slope. What is D0?
Market size.
It is the market size. And remember, this formula comes from an equation where you take it as minus MP. So epsilon is MP by D0 minus MP. So whatever is the value of M, you will take the absolute number here. Let's say M is 10. You will not substitute minus 10 here. This is wrong. You will substitute it as 10. Fine? Because this entire formula is derived with the minus sign in the equation. Okay? All of you clear?
Yes, sir.
Now, if I give you a curve like this, D0 plus M, let's call it plus 20 into P. What will be epsilon? What will be the formula for epsilon?
MP, M is
M is
minus 20
into P.
P by D0 minus plus 20 P.
Minus or minus 20 into P. Okay. So remember, this M, you will take it as a negative number. If the equation is a positive sloping equation, you will take it as the absolute number if the equation itself is a negative sloping equation. Because that is how the derivation is happening. So this derivation is derived from this equation So the negative sign does not come in the numerator and it comes in the denominator. If it was the other way around, it will be the other way around. So if it's D naught plus
But
MLCT,
sir,
yeah.
Suppose they have given elasticity, constant elasticity as 0.9, because there's one question in the PA wherein the elasticity is given and we are asked the course fee is rupees 10,000 and 1,500 students have registered. If the course fee changes to 8,000, how many students will register? So in that case, elasticity should be taken as minus 0.9 or how is it?
No. You'll just take it as 0.9.
So that's what, when I took 0.9, I got an answer which was also there in the list, but the answer that is given is they have taken minus 0.9 and worked it out. I don't know whether I am wrong, but PA4 fourth question.
Let me maybe check the answer. It could be a very old PA. Course velocity, the number of students registered is expected to be constant at 0.9 for the next couple of years. Currently, the course fee. This question, how did you solve? You solved it using which one? This equation, no?
I have solved it using no. I have solved it using yes.
If you use this, you have to take the negative, no?
Oh, okay, correct.
Because the slope is not given, whatever number, by default take it as negative. So that is why.
Okay. Yes. So I should, if I had taken this formula, I should not have. I can take the absolute value.
Correct.
Okay,
you cannot take this formula for that question. Why? You cannot take that formula for this question. Why?
So we have to find
because
one of the values there, which was in the first case, the first formula.
Okay, that is one way of looking at it, analytically looking at it. Conceptually, why?
No, it is given, it is asking for between two price points.
Okay, that is what I'm telling to say. That is mathematically looking at it. Since it's 2 points, I have to use two values. But logically, why?
Sir, because we don't know the nature of the demand response curve between the 2 points.
Absolutely,
and also we don't know the slope. We don't know the slope.
You are given the elasticity, you are given this thing.
No, we are not given the slope.
Okay, you are not given the slope, so it will become that. No? What is even more intuitive? Now tell me, what is the topic? I started off this discussion by telling something over here. We are going to use elasticity for a simple dash regression. What regression?
Linear.
Which means my curve is going to be?
Linear.
Linear. So for a linear curve, will elasticity be constant at all points?
No. Constant. There is another.
Constant?
No.
It will not be constant. The elasticity will change. The next unit, week 5, if you guys go through it, that is where we talked about a constant elasticity curve, which will not be linear. It will be parabolic. It will be a non-linear curve. I should not say parabolic. It will be a non-linear curve. So once the curve becomes linear, the elasticity will not be constant. It is not constant. Very rarely. Or let me not say is not. Need not be. Need not be constant. But in a constant elasticity curve, which is talked in, which will be spoken about in next week, the curve will become non-linear. The curve will become non-linear, and there, how do you solve is unit 5. I'm not getting into unit 5 today, but that is going to be unit 5. So in this case, once I tell you that the thing is going to be expected to be constant at 0.9, since you do not know about non-linearity curves, leave that out. Since you do not know constant elasticity curve, leave that out. You can by default say, in a linear response curve, it need not be linear. Then you apply the logic. I've given you 2 different points. no mean, no slope, so it has to come in the first form. Okay.
Yes, sir.
That is a very this thing mathematical way of thinking about it, or logical way of approaching the question. Good. So what we usually do is we mix and match questions and give in the exam so that you'll be able to come out of this guy. You'll be able to distinguish between this guy, this person, and the next person. In fact, even in this, what we say is it will come in unit 5. So in week 5, IITM BA's course elasticity for number of students registered is expected to be constant. I am only telling the elasticity is expected to be constant. I am in fact not even make any comment about the nature of the curve, whether it's linear or it's a constant elasticity curve. There are two different things. The elasticity of the curve being constant is different. The elasticity being constant is different, right? So here only the elasticity is going to remain constant. And it's only for the next couple of years. It could be, let's say after 2 years, it could change. But in a constant elasticity curve, it will remain constant throughout. Fine. So all of this I'll cover in week 5 when we do it. Okay, all of you clear up to this point? Any questions?
Yes.
Yeah.
So when slope is negative, so we take m is equal to minus 10.
No, you take m is equal to 10.
If
This
negative,
formula, you take it as m is equal to 10. If d0 is equal to minus m into p, if this is your curve, you take 10.
Okay.
Okay. Clear?
And here, if d0 minus mp, so here m is
plus 20 into p. If this becomes positive, you take the negative value for the elasticity.
Okay.
Okay, everyone clear? Because this formula epsilon is equal to mp by d naught minus mp is derived with a negative sloping equation. The source equation is this from which you derive. So the negative sign is already taken into consideration in the derivation. So you don't put it in the negative sign over here. So when you alter the equation, when it becomes a d0 plus 20 into p, the derivation remains the same. The negative sign gets added to the m.
Sir, is it because elasticity is generally negative?
Not necessary, no?
The
So here,
equation has
when
been
you substitute epsilon is equal to mp, it will not be a negative number, no? How will it be a negative number? Only
no, I'm
if the
asking,
denominator mp becomes very large, it will become a negative number, or else it need not be, no?
I'm asking why is it taken by default negative? Is
So
it
this
because
one, d0 minus mp, why that equation is taken negative?
yes.
Okay. That is because most goods, as the price increases, the demand decreases.
Yeah,
So
yeah.
that is the reason why you take. But there are goods which operate in the other sense as well. As price increases, demand could go up. Right?
Got it.
So in that cases, you will use the other way around for the elasticity. Okay, all of you clear? Any questions on the topic of elasticity?
so. So here, as prices increases, demand is decreases.
Yeah.
So then, slope is going to be positive. This part is, can you?
Which one?
Take,
Look,
through
it's going like this. The line is basically going to be something like this. This point is your D naught. When price is 0, this is price. This is D of t. When price is equal to 0, you have D0, which is the market size. And what is this price?
some P.
What is that price called?
Satiating price.
This is the satiating price. This is the satuating. Satiating. Hey, I'm not able to write these things on the board, man.
Satiating or satiating?
Satuating. Satiating. Okay. What is the satiating price? I would have asked here. Parameters, hypothesis. I have not asked it here. ATING. This is right. Satuating. It's satuating price. The price at which demand becomes zero. Right. So that is going to be, let's say, T0. So how do you find T0? So this is going to be your curve. So as your demand, as your price increases, the demand is going to be decreasing. Right?
Yes.
Okay. So what is your doubt here?
No, sir. Clear.
Okay. So this is what is going to be happening. And the most important thing, okay, I'll move on. So the problem is we are going to model this as an SLR, simple linear regression. And when you model it as an SLR, in your Excel, you'll get three values. You'll get beta naught. Since time is short, I'll stop here. Beta naught, beta 1. You'll get these two values, beta naught and beta 1. If this guy is positive, what does it mean? What is the equation going to look like? Y is equal to, if this guy is positive, what is it going to be looking like? B naught plus B1 into T. Y is basically D, right? So this is D of T is going to be B naught plus B1 into T. Your B1 is your slope. And if that guy is positive, your entire equation basically resembles something like this. So when you are given a simple linear regression, and if the coefficient of x value, beta 1 coefficient, is positive, you are getting this type of a curve, which means the curve is moving like this. And in this case, your m is positive. So when you are used to calculate your epsilon, you should take minus beta 1 into p by d naught minus of minus beta 1 into p. This will become the formula. So please note the small thing. Everyone will be very clear up to this point, where there's a difference between d0 is minus m into p and this. But when you fit the regression, you should be able to interpret it saying that this is a positive sloping curve. So the epsilon should carry the negative value. And this is a negative sloping curve. So the epsilon should just be beta 1 into p by 1 by d naught minus beta 1 into p. Okay? Everyone clear?
Oh, yes, sir.
Any other questions in this? I just checked. I was originally right. It is a satiating price. Satiating. Satiating is not right. Satiating price.
So this beta naught and beta 1, can you explain once again? This.
What is a simple linear regression? Why is it okay? Let's look at it in this sense. There are three terms here. Simple linear regression. So it is called simple linear regression. This is the name of the technique. This is SLR. Why is it called regression? Why is it called linear? Why is it called simple? Any guesses, anyone?
When we have one dependent and independent variable, it is simple.
Okay, when there is only one, let's not go into dependent variable, multimodal regressions, but one independent variable. Okay, one independent variable is simple. Then why is it linear?
Straight line is used.
It's a straight line relation. And what does regression mean?
It is used for continuous values.
Regression means the dependent variable must be a continuous number. That is okay. But what does the term regression imply?
To study the relationship between dependent.
It's a relationship. Okay, so it's a relationship. So a relationship which is modeled as a straight line with one independent variable is called the simple linear regression. That is why it's called simple linear regression, the name itself. Now, in our case, this is the general simple linear regression from beta naught plus beta 1 x. This is the general simple linear regression form. In our case, what we are doing is we are replacing this with the demand response curve and telling d of p is equal to beta naught plus beta 1 into p. Instead of x, we are replacing it with p, and instead of y, we are telling it's d. You can also call it d of p or d. Both mean the same thing. You can either write this or you can write this. Both mean the same thing. It's a function of p, right? So now this becomes your core concept. I'm going to model a demand response curve as a simple linear regression. So based on the data, the equations can either look like demand is equal to beta naught plus beta 1 into p, or it could look as d is equal to beta naught minus beta 1 into p. This regression line is for a data which goes like this. This regression line is for a data which is like this. This is p, this is d, this is p, this is d. Okay, and what I'm trying to say is, if you get a regression equation that looks like this, the epsilon is beta 1 into p by d naught minus beta 1 into p, and in this case it's going to be minus beta 1 into p by d naught minus beta 1 into p. What is d naught? Market size.
Market size.
Which is equal to?
Demand when price is 0.
Which is equal to in SLR?
The first one, it should be d naught plus beta 1p. The denominator should be.
Sorry, yeah.
First one.
Should be plus, correct. So in this case, yeah, you're right. This should be plus, my bad. So d naught is equal to, in a simple linear regression,
Intercept or base value.
Intercept or base value, which is beta naught. So this is what I wrote here. Okay.
Yes.
Everyone clear? I'll talk more about this maybe in next week's lecture, or 2 weeks from now. Week 6, you might have MLR. At that time, maybe we'll dive deep into why an ANOVA table has the different concepts and so on and so forth. Okay. Any other questions from weeks 1 to 4?
So can I have a question here?
Yeah, go ahead, Mark.
Yeah, what I'm asking is how is this correlation coefficient related with this beta 1?
R squared.
Yeah. So it's a correlation coefficient is basically if I take beta 1 and corresponding to correlation coefficient, they should be related, no?
Correlation coefficient you will not get for beta 1, you'll get for the model.
For the model, I'm saying, from where can we get?
R squared you will get using the ANOVA table, no?
Yeah,
R
yeah.
squared you will get using SSR by SST.
Correct.
Which is 1 minus SST by SST, same thing.
Correct.
So this is how you will get the R squared for the model.
Right. So what I'm asking is, I'm just asking a very silly question maybe. Like, say, for example, D is, say, D versus P versus D you are, plotting. Say, for example, X and Y are two variables. If I make the Y variable as the the explanatory variable, and Y instead of Y to be response, I make it Y as a explanatory and X as the response.
Okay.
The correlation coefficient should not change.
It will not change.
It will not change. But if I try that on Excel, a set of 5 numbers X and set of 5 numbers as Y. If you do this and get a plot on a figure, the figures are different.
The figures in the sense values are different. Values of R squared will be different, but the correlation coefficient is R. Square root of R squared is R.
Okay.
That number should be the same. Why are you getting it as different? In an SLR, are you doing an SLR first and foremost?
No, I was just doing it in just for my understanding. I was doing it
when you are doing it as this thing, you used only one X and one Y, correct?
Yes, right.
And you when you interchanged, instead of Y, you used it as you used Y as a dependent variable, X as the independent variable. Then you changed X as the independent variable, X as the dependent variable, Y as the independent variable. Correct?
In that case, R square should be same, in both cases.
R square should be the same.
I think it did not come. I don't know where.
Just check. You might have made some errors.
Some errors.
Correlation should be the same.
Okay.
SLR it should be the same.
Okay.
Okay. Anything else? One question here, Alok. Have you subset this data from a larger data? You have Y, you have an X.
Yes.
Then it should still work. But you have a Y, you have an X. Yeah, let's say you have Y and you have several X's. From that, you just took one column and you built this.
No, what I did was I just at random took say 5 or 6 X and 5 or 6 corresponding Y.
Try doing this now. Instead of going so far, just say you create an equation Y is equal to 4 plus 5 into X plus some random epsilon. Okay. Plus some random number.
Okay.
Just use rand between let's say between 0 to 5 and create one epsilon. Now you have created a data set. If you fit a SLR for this using Y and X, you should get this equation. If you fit it the other way around, you should get the ulta equation.
Yes.
Right? You should basically get minus 4 by 5 as one coefficient, and the other coefficient should be 1 by 5.
Correct.
Right. So something of this sort.
Something of this
because of the epsilon it might change, but you should almost get the same numbers.
R square should be same. That's what I mean.
Just try this thing.
Fine. I'll just.
Just try this for a data set and check it out. Logically speaking, it should be the same. I will also do it, but yeah. Anything else? Any other questions from anyone? Okay, so if there are no more questions, no more questions, then we'll wrap up for today. All the best for your quiz on Sunday, right? Well, and one more thing, we will discuss quiz 1 on next live session. All right. This session will not be recorded. Will not be recorded or streamed. Right. So please note that the next live session, the discussion on quiz 1 will not be recorded. After that, if I cover any content based on time, we will have that. I will record that and post it on YouTube. So the quiz 1 solution discussion will not be recorded. We expect everyone to come and interact.
Sir, what are the timing for this session?
The same thing, Mas. Next Tuesday, 9 to 10. So the quiz gets over on Sunday. The immediate next live session, we will discuss the quiz.
Okay.
Okay. So the date should be, when calendar opens, it should be the 29th. So this is basically on the 29th of October. Okay. And one more request. Before you start raising concerns for the quiz on discourse, please wait for the answer key to be released. Don't raise questions based on your memory of a question. So that is one request. Second request, I will be creating a dedicated discourse thread for the quiz one discussion. So post your questions there. Please read past post before you create a new query. If someone has already raised a query, please like it and wait. Either me, okay, only me. I will be responding to that query, and based on my response, if you still have concerns, raise it again. All right? Because if you constantly raise the same concern, let's say if someone posts in question number 1, I had this number is not matching. If after that 10 people say yes for me also, yes for me also, yes for me also, there is no value being added, number one, and it becomes a long thread for me to keep track of all the other questions that are coming, right? So if someone has posted a question, please like the post and please wait. I will respond as soon as possible. Once my response for a query has come, and if after that you still have a concern, you can raise it. Fine, and we'll have a discussion on that. Okay, so just kindly follow these basic things because it will become easier to keep track of the post and the corrections. Okay, so that is all from me for today. We'll meet again next Tuesday, and all the best for your quiz. We have 16 people on the call. If it drops below 8, I will also log on.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.